Unit 12. So, we're going to do some physiology of birds. ACER likes birds and fish for some reason. I don't know. But humans come up a few times, but birds and fish are well represented. The main tube, trachea, that starts at the back of the mouth. Okay. Bronchi, no gas exchange in the bronchus. And then they talk about the sacs, which are the posterior and the anterior sacs. Okay, and then in figure 2, it shows you that for the alveolus, for a mammal, there's the gas that is going in and out, but they're using the same conduit to go in and out. That's what we do. That's how we breathe. And then there's the bird and its parabronchus, which has one-way movement of the air, and I'm sure that increases the efficiency of breathing for birds. Something that you can be thinking about while you're reading. And so on the next page, figure 3, we can see that the during inspiration A, you can see how the irradiated gas moves inside the animal, and then you can see it B in expiration, it goes through the lung part where there's gas exchange, and then C, inspiration. Now we have oxygenated air that is in that posterior or the anterior part of the animal, and then expiration D, and the air leaves. Okay, and finally it gives a little summary of human breathing with the trachea and the lung, and the diaphragm is lowered, of course, for humans, and the rib cage expands, and that reduces the pressure in the lungs, creates negative pressure, like I said, for another problem that we did earlier, and so the positive atmospheric pressure comes rushing into the lung as a consequence. So the first question is, for the single breath of radioactive labeled air, gas exchange in the bird occurs mainly during, and it's asked which stage, and so clearly you can see it's B, expiration, because that's when you see the radioactive substance flooding the area, which is the lung, and that is where the bird has gas exchange, because we've been told that in the sacs, that the anterior and posterior sacs that the bird has, that they are poorly vascularized. That means there's not a good number of blood vessels going there, and that means they wouldn't have lots of capillary beds that are open where gas exchange can occur. So 42 is B. 43, unlike the human respiratory system, in the respiratory system of the bird, it says the lungs are not vascularized. No, that's not true at all. Their lungs probably are extremely well vascularized. The issue is the sacs that push and pull air into the lungs are not well vascularized. B, the diaphragm operates only during exhalation. Actually, the passage never discussed any diaphragms in birds, and in fact, we have to assume the opposite. We have to assume that diaphragms, it doesn't look like the bird has any need for a diaphragm, because the bird has these anterior and posterior sacs that are pushing air into the lungs and pushing air out of the body. So we have no comment on the diaphragm issue for a bird. And then C, air gets into the blood by mechanisms not involving diffusion. That certainly wasn't discussed, and that's certainly illogical, because we know that in mammals, oxygen gets into our blood system through simple diffusion in our lungs at the level of the alveoli, and carbon dioxide leaves our blood system, carbon dioxide being a waste from metabolic respiration, and it leaves our system through simple diffusion, again at the level of the alveolus, which is surrounded by capillary beds. So then we're left with air does not trace the same path during inhalation and exhalation, and that's quite clear. When you look at at both figure 2 and figure 3, you see how the air moves in the system, and this is quite different from the way it works. We use the same passages going in and out of our lungs. So 43 is D. 44. Which of the following human structures is most similar in function to the bird's sacs? Now, keep in mind, the bird sacs are pushing and pulling, well, not pulling really, but pushing air into the lungs and then pushing the air, out of the lungs and sort of contracts and expands during a breathing cycle. And so certainly a single lung doesn't do that for us. Our lungs don't actively contract and expand. And in fact, we saw a passage about that using the example of a balloon expanding. So, and a single rib, no contraction, and neither for the trachea, which is a conduit, and it does not. But the diaphragm, of course, it contracts. And when it relaxes, so by going through these parts of the breathing cycle, it helps to bring air into the lungs. So diaphragm would be the answer, and that's 44B. So moving on, number 45. Air is exhaled from the bird during, and so stage 1, this is stage this and that. Okay. So, actually, this is unusually easy from ACER's point of view, because if you look at figure 3, just look carefully in the two boxes. Twice you see the word expiration, and it's for the letter B and for the letter D. And indeed, air is being pushed out during this. Now, of course, you might complain, but hey, what about that radioactive stuff? Isn't it moving through only once? And that's true, but there's air before it and there's air after it. And so, during a normal breathing cycle, the bird is probably not breathing radioactive air, and during that normal cycle, there's expiration at both B and D, as ACER, wrote there in the figure. 46. A large bird and a human. Yeah, I guess it had to be a large bird if you're comparing it with a human. Both breathing at a constant rate of 10 inhalations per minute. Each begin to inhale radioactive labeled air. Assume the durations of inhalation. Okay, compared with when it first begins to be exhaled from the bird, radioactive labeled air will begin to be exhaled from the human. Okay, so we're talking about a respiratory cycle where there's inhalation and exhalation. Now, there's 10 inhalations a minute. So that means, so we have 1 minute. There's 10 inhalations, we are told. And so if we go 60 seconds is in 1 minute, so that our minutes cancel. So we have seconds. So we have 6 seconds. 6 seconds for one inhalation. And of course, there's exhalation occurring between the inhalations. So compared when the respiratory cycle, inhale and exhale. So when we breathe in, as soon as we inhale, as soon as we exhale, just look at figure 2 for a second. And when you see figure 2, you see we're using the same conduits to go in and out, and that goes for our entire respiratory system. So as soon as we inhale anything, when we exhale, some of the air that we just inhaled is being exhaled. That's the first moment that we are getting an exhalation. Whereas for the bird, if you look back at figure 3, when it inhales in A, okay, we see the radioactive material there. It exhales, it does not leave the body of the bird yet. it inhales a second time, and then it exhales. And now, finally, when it exhales at D, does the air go out. So in other words, so they have one extra respiratory cycle compared to us. So we would breathe out on our very first chance, and they would breathe out the air on their second chance, which would be at 12 seconds. So humans would breathe out that air 6 seconds earlier than the bird would. So question 46, the answer would be C. Now moving on to question 47. Members of which one of the following pairs have the least similar function? And A is lung and sacs. Well, that's clearly the answer, because as I've said already a couple of times, the sacs are not well vascularized, and they seem to be behaving like a diaphragm in which they're helping to get the air in and out of the lungs of the bird. Whereas Antitroids B, their lungs sort of work like our lungs in terms of the lungs themselves exchanging gases, carbon dioxide and oxygen. And then C, alveoli and parabronchi, do they have similar functions? Sure they do. Alveoli have the exchange of gases, and the parabronchi in the birds have exchange of gases. And Antitroids D, bronchioles and parabronchi. These are similar for two reasons, actually. The obvious reasons is they're similar because they're both conduits through which the gas can pass. Oxygen and carbon dioxide and so on. So they're both conduits. But did you know that of course the parabronchi have gas exchange, but bronchioles also can have gas exchange, because there's two types of bronchioles. There's respiratory bronchioles, and then there are different types like terminal bronchioles, and there's bronchioles that are just conduits, and so because of that, they are definitely very similar and shared functions. So A would be the correct answer, 47A. 48. According to the information provided, which of the following is likely to be the most important reasons anterior and posterior sacs contract simultaneously and expand simultaneously? Well, if you had to guess, you'd guess that it's to avoid the air going into the wrong direction. When you just look at figure 3 and you see how everything just moves through the system like that and not going backwards and so on, it seems to be a system that is coordinated so that it can be that way. So A, the answer to help airflow in the correct directions, yes. Otherwise it would be going in both directions at the same time. So A is the correct answer. B says to maintain a high air pressure in the lungs, and that's wrong, because it's not to maintain a high air pressure. The air pressure must circulate. It must be high and low and high and low in order for the air to move in and out. And then C, so that one breath of air in the respiratory system at any one time. No, there's 2 breaths of air at least, in the respiratory system at any one time, because that's why their cycle is longer than ours. Because regulation of central nervous system, blah, blah, blah. Well, we just don't have any information about that. So, so there was a lot of information about directional flow, but no information about central nervous system control. So if you wanted to read more about the respiratory system, you can go to the book in these sections to get some background information.